Children, let us see now what is laws of chemical reaction. So, what are the laws? There are 5 laws. One is law of conservation of mass. Conservation, you know, that is preserving. Okay, yeah. Next one is law of constant proportion. And the third one is law of multiple proportion. The fourth one is law of reciprocal proportion. And the last one is Gay-Lussac law of combining volume. So, the 3 laws can be applicable for solid, liquids and gases. The last one is laws of Gay-Lussac law of combining volumes. It's purely for gases, not for the solid and liquid. So, first one will say laws of conservation of mass. Maybe you would have studied in 8th standard. Okay, yeah. So, laws of constant conservation means what? Joining like mass. So, whatever it, as per that, energy is neither created nor destroyed. The weight of reactant is equal to weight of products. You would have studied in the lower classes. Okay, yeah. So, your chemical reaction, the arrow mark, before arrow mark, that is reactant. After the arrow mark, product. That is reactant is equal to product. Weight of reactant is equal to product. Okay, yeah. Because in the book it's given already, you have studied in 8th standard. Law of constant proportion. So, whatever the method you prepare the compound, they are in the fixed ratio only. For example, water, we are preparing by using many chemical, the ratio is 1:2. This is what I said, constant proportion. Now, we have to go for law of multiple proportion, that is given in our textbook. Now, we have to say, this is just simply I am explaining what is it. This is right side is equal to left side. Okay, yeah. Reactant and product. What is chemical equation? For example, calcium plus chlorine gives calcium chloride. We are balancing the equation. Right side is reactant, left side is product. The right side is equal to the weight of reactant is equal to weight of the product. Here calcium 1, there also calcium 1, chlorine 2, chlorine 2. This already explained in 8th standard. Okay. Then conservation of mass, constant proportion H2O, whatever the method may be, the combination of hydrogen plus oxygen to H2O. This is balancing, but ratio you are saying means hydrogen always 2:1. That is 2 atom of hydrogen will combine with 1 atom of oxygen. This is what constant proportion. Now we have to see law of multiple you know product. We have to say that is same element, it combined with other element in a simple multiple ratio. That is 2 element taking part in the reaction. One element is constant, other element is combining in different forms, but in the simple ratio only. Other ratio pathina 1:2:3 like that. In our textbook it's given the, so it is proposed by John Dalton, underline. It may be match the following like. So what is law of multiple proportion? It is proposed by whom I say? John Dalton. Here when 2 elements A and B combine together, so put a break here and there is some intonation, then only you can follow what it is. When 2 elements A and B combine together to form more than one compound, elements combine panna, they will be a compound. Then different masses of A which separately combine with B fixed in a simple ratio. That is 2 elements we are taking. Here one example is given for us. We will see now. Shall I go there? First we have to see law of constant proportion, law of constant proportion, law of multiple proportion. Okay, Amma, law of multiple proportion. What I said now? When two elements A and B combine together to form more than one compound, the different masses of A combine with a fixed mass of B in a simple ratio. Here we are taking two elements. One element is carbon. First element is carbon. Second element is oxygen. First mass of one is carbon monoxide, other one is carbon dioxide. A mass of carbon, a mass of oxygen, mass of compound. Yeah, okay, yeah. Two elements, one is carbon, other one is oxygen. Carbon is constant, oxygen is combined with this in a simple ratio. Carbon and oxygen together, they form more than one compound. One compound is carbon monoxide, other compound is carbon dioxide. Clear? Now you see, mass of carbon is 12. In both the cases, weight of carbon is what? 12 only. But mass of oxygen, here, only one. How many oxygen there? One oxygen only. So 16. Here mass of oxygen is 2 atoms. So 16 into 2, 32. So mass of carbon dioxide we have to say, ratio we have seen means this is 16 ones are 16. Okay, yeah, 1. This is 16 twos are 32. What is the ratio? Simple, mass of carbon dioxide and carbon monoxide is 1:2 ratio. Clear? Two different element, one is carbon, it's always in the same ratio only. Oxygen combined with form carbon and makes more than one compound, that is carbon monoxide one compound, carbon dioxide one compound. So rendum compound பண்ணும்போது here the ratio is, first one is only one oxygen atom 16 gram, second one is 2 oxygen atom 16 into 2 32, ratio is 1:2. Is it clear? Shall you go for other one? So law of multiple proportion, let me say again the law. When two elements A and B combine together to form more than one compound, then the different masses of A is separately combined with the fixed mass of B. Clear? Next one is laws of reciprocal proportion. Reciprocal means what? We are saying taleke, okay, yeah, laws of reciprocal proportion. Here, this is said by Jerry Richer. Underline the scientist name. If two different elements combine separately with the same weight of the third element, here how many elements are taking part in that? 3 elements. 3 elements. So A, B, C for example. One element is hydrogen, other element is carbon, third element is oxygen. How many elements are there? 3 elements. Hydrogen, carbon, oxygen. See the diagram in page number 133. If two different elements combine separately with the same weight of third element, that is A and B combined with C, the ratio of the masses in which they do are either same or simple multiple proportion. For example, we will see at the back. See the next one, the same like, we will go for multiple proportion, compounds. Then combining elements. And next column is combining weights. Okay, yeah? First one is compound, second one is combining elements, third one is combining weight. That is elements how they are. This is law of reciprocal proportion. Reciprocal, what I say? Elements. Reciprocal தலைகீழ் விகிதம். Okay. Here, what are the compound? CH4, that is methane. That is 1 carbon atom, 4 hydrogen atom. The number represents the number of atom present in the reaction. Here CH4, is there any number next to C? No. That means what? Only 1 carbon atom. Hydrogen, what's the number there? 4. So 1 atom of carbon combined with 4 atom of hydrogen and become methane. Okay. Next compound is carbon dioxide. Here carbon is one atom only. Oxygen how many atoms? Say 2. Okay. Then what are the compound combining elements? Here carbon, then hydrogen. Here the combining element is carbon and oxygen. What's the ratio? Carbon 12 only. Hydrogen, I said already, how many hydrogen there? 4 hydrogen. Here oxygen how many? 2. Sorry, 2 means 2 16s are 32. Atomic number of oxygen is 16. So 16 2s are 32. Clear? Carbon, atomic number of carbon is 12. Here both the cases how many carbon atom there? Only one carbon atom. So 12. Here hydrogen how many? 4. Atomic mass number, atomic number whatever it may be, it is 1 only. So 4 ones are 4. Here carbon dioxide, atomic number of mass number of carbon is 12. Mass number of oxygen, how many elements there? 2 elements, 2 atoms. So 16 into 2, 32. What is the ratio? 4 is to 32. That is 1 is to 8. They are in simple multiple proportion. 4 8s are 32. That is the multiple thing. So here the laws of reciprocal proportion. Again just go through. If two different elements, what are the two different elements? Hydrogen and oxygen. Two different elements combined separately with the same weight of the third element. What is the third element here? Carbon. What is the same weight? 12. Carbon weight, there is no change in the carbon weight. Two different elements, hydrogen and oxygen. They combine with the third element, that is carbon, the same weight. Okay. They are simple multiple, they do so and all, you no need to learn, or else you do learn like this. If two different elements combine separately with the same weight of a third element, till that no doubt. Clear? The ratio of the masses means what? Weight, which they do so are either same or simple ratio, simple multiple ratio, in which, okay, this is the law. This is laws of reciprocal proportion. Next one we have to see Gay-Lussac law of combining volumes. This already I said, this 4 law may be applicable for solid, liquid, because element exists in 3 states, solid, liquid and gases. The 4 laws we can say for solid as well as liquid, but gases only Gay-Lussac law of combining volume. Here this is introduced by a scientist, Gay-Lussac. So just to honor the scientist, all the laws are named by the scientist only. First one what I said, law of multiple proportion by whom? John Dalton. Just underline the names of the scientist. Law of reciprocal proportion by Richter, and laws of Gay-Lussac combining volume, that is Gay-Lussac. According to Gay-Lussac law, whenever gases react together, here important gases must be, the volumes of the reacting gases bear a simple ratio, and the ratio extended to the product when the product is also in gaseous state. That is, reactants also in gaseous state, product also gaseous state. For example, oxygen, carbon. For example, we can say like this, carbon plus oxygen, carbon dioxide. Here carbon also gas only, oxygen also gas, they become carbon dioxide, that also was gas. So this is reactant, this is product. Under similar condition of temperature and pressure. So, எந்த ஒரு gas we have to see pressure, temperature, volume. So, they provided all the volumes are measured under similar condition of temperature and pressure. All the 3 laws you should be thorough. So, whenever you want to give a gap, you can put a dash and land like this. You can just divide that according to Gay-Lussac law. Whenever the gases react together, the volume of the reacting gases bear a simple ratio. That's the first part. Then second part, and the ratio is extended to the gaseous state provided all the volumes are measured under the same condition of temperature and pressure. Clear? Now we have to see for the last one, quantum numbers. Is it clear? All the 5 laws, it's clear for you. Now we have to go for quantum numbers. Quantum numbers, we said already, no, there is the suborbits are there, K, L, M, N. Suborbits are present to that, that is known as what? Quantum numbers. So we said, suppose for example, the Google search and all, our address is there means it's clearly stated where it is. Tamil Nadu, Chennai, Muttamanagar, and the area. Like that, we can, on seeing the quantum numbers, we can find out the position of the elements. So, for example, electron, we can see what is the property of electron, what is the property of proton. So, like that, we can find out the chemicals, atomic structures, that is known as what? Quantum numbers. What are the 4 quantum numbers? Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. It's given in the tabular form, you see. So, we have seen what are the laws, what are the chemical laws of combining. Now, we have to say what are the quantum numbers. What are the quantum numbers? First one is principal quantum number. That is represented by N symbol. So, this is the main energy level. By the principal quantum number, we can find out what is the which electron is which level it is. What is the main energy level? Energy level means what? Orbits. Electrons are revolving around it. So, by using principal quantum number. Next one, azimuthal quantum number. Third one is magnetic quantum number. Fourth one is spin quantum number. There are 4. First one is represented by N, azimuthal by L, then magnetic by M, spin quantum number by S. So, all the 4 numbers, all the quantum numbers, it represents the position of electron. Principal quantum number says, then where is the electron, which main energy level. Azimuthal quantum number says, what is the subshell. For example, what are the thing? What are the subshell? For example, K, L, M, N, subshell S, P, D, F. So, K varanda S mattumda, L varanda SP, M means SPD and N SPDF. These are the subshells, and we can find out what is the subshell. And the last one, magnetic quantum number, this is orientation of orbital. We can find out the orientation, where it is located. Okay. And the last one is spin of the electron. How the electron revolves in that. Spin means what? Rounding up. Okay. By knowing all the 4 quantum numbers, what are the quantum numbers? Principal, azimuthal, magnetic and spin. We can find out the energy level, and we can have a clear idea of electron. So, first one says what is the energy level of the electron. Second one says in which subshell it is. Third one from where it is oriented. Fourth one is how it spins. Okay. So, thus we are completing this lesson. So, just go through the thing. I said keep the book next to you, then only you can follow what is what. Clear. Thank you.